The TGF-beta pathway stands for transforming growth factor. This signaling pathway is involved in many pathways such as embryogenesis, cell differentiation, proliferation, and apoptosis. TGF-beta is a large family that is related to other ligands such as activins, BMPs, and GDNF. Let's see how the pathway works. We are now looking into a cell with its cell membrane and nucleus. On the cell membrane there are receptors type 1 and type 2. When the TGF-beta ligand approaches the cell, it binds to dimerized receptor type 1 and type 2. Phosphorylation activates these receptors where we can see type 2 receptor phosphorylating type 1. This allows for the phosphorylation of SMAD2/3. Phosphorylated SMAD2/3 binds to SMAD4 and makes a complex that goes into the nucleus. In the nucleus, SMAD2/3/4 act as transcription factors and regulate a target gene. One function for the TGF-beta pathway is its involvement in connective tissue development and proliferation. These tissues are made up of proteins that help protect and support organs in the body such as the heart. Connective tissue growth factor, TGF, helps in the development and proliferation of connective tissues. Connective tissue growth factors can be induced by TGF. We can look at this pathway by starting at the SMAD2/3/4 complex. When this complex goes into the nucleus, it will act as a transcription factor and regulate the expression of connective tissue growth factor. These factors can then leave the cell and help in the development and proliferation of connective tissues. Under normal conditions, the TGF-beta pathway with connective tissue growth factors helps in the support and protection of organs like the heart and the bone. However, when mutations arise, it can cause changes in the TGF-beta pathway which can result in disorders. Marfan syndrome is a disorder where connective tissues are affected. This leads to symptoms such as long extremities, slender body, and an aortic enlargement. This syndrome is caused by a mutation in the gene that encodes for fibrillin 1. Fibrillin 1 is a protein found in connective tissues which helps in structural support. This mutation causes excessive TGF-beta activation which leads to symptoms such as heart defects. Let's see how this happens. When the fibrillin 1 mutation occurs, the large latent complex, LLC, can't bind to microfibrils. This causes an excess of TGF levels and activation of type 1 and type 2 receptors. This leads to excess SMAD2 proteins and increases the production of matrix metalloproteinases, MMP, expression. This increase leads to vascular remodeling where there are aortic enlargements, thoracic aortic aneurysms, and changes in the aortic wall. Additionally, this mutation can cause another mutation on the type 2 receptor which prevents the TGF-beta pathway from happening and causes Marfan syndrome type 2. Researchers are now looking at ways to improve the lives of people with this syndrome. With all of this being said, there are different signaling pathways that affect the development and changes to the body. Each pathway is complex and can work together to perform many functions. Thanks for watching.